So dynamic or random access of the data is not possible with your big data. So we need to run a batch job, and the result of that you will be able to get the answers. So the problems of your traditional RDBMS are being addressed in your big data. Storage is not a problem. Processing is going to be very fast. Okay, in Hadoop. But random access is not possible there. You cannot randomly access the data. I mean, like how I mean, this is not best suitable for transactional activity. That I can say simply. So if you observe closely, big data is moving towards this. Big data is getting matured to get fit into the transactional activity also. Databases are moving towards the cluster concept and all. I mean, moving towards unlimited storage and high computing power. Over a period of time, I'm sure your traditional databases will no longer have those concepts in the backing, and big data will not have whatever you are seeing currently. So you will be seeing, yes, this part. So where storage is at your choice, processing very fast, and best suitable for even transactional activity. So such kind of databases we'll be seeing in the coming days. Okay. So even now you see slowly the concepts of big data are getting adopted into your traditional RDBMS. So they're now working towards that. Same like even here, as part of the operating system aspects, you see the Red Hat Enterprise Linux 6, not before that. Red Hat Enterprise Linux, that is the reason why this resource management in terms of your cluster also taking new dimensions. It was not there before. Red Hat Enterprise Linux 6. So obviously CentOS 6 also. What version you have as part of Red Hat? Same version in terms of your CentOS also. But this is a community edition, that is a proprietary edition, a paid one. Red Hat Enterprise Linux 6 provides a new kernel feature. You need to understand that here. A new kernel feature. What is that? Control groups. That is a kernel feature, not at the user space, which are called by their shorter name C groups. C groups. C groups allow you to allocate resources, because ultimately the goal of this one is to allocate the resources to your process running inside it. That is a goal, ultimate goal. So C groups allow you to allocate resources such as CPU time, system memory, network bandwidth, or combinations of these resources. I think you got this point till here. This is the information that is being taken from Red Hat documentation. This is nowhere related with your. This is nowhere related with your the Hadoop cluster or Cloudera. The only reason why we are discussing that, let me also give you that introduction so that you will not be confused why we are discussing all these things. I think you noticed here, enable C group based resource management. You got this point, friends? Enable C group based resource management. Okay.
So basically, I can define users of the operating system and I can control resources that the user can use, right? That's what it does.
Fantastic, Arun. So similar kind of thing even you see here. Similar kind of thing even you see here. You can go to your cluster and say, you go to the static service pools, and there you have the configuration. So that what happens? You see that here. For HDFS, for Impala and your yarn, what percentage of resources need to be used? So you decide that one here. Accordingly, this is at your cluster level. You are getting my point? This we are doing at the cluster level. This we are doing at the cluster level. But ultimately, where these needs to get reflected? I am making these things at my cluster level. But where these things need to get reflected?
On the server.
On the server in the sense,
At, at the host operating system level.
exactly. So these things need to happen. These things need to happen at your individual host, because you know very well with the Hadoop, whatever the configurations you do at the cluster level, they actually get applied to each host. This is a host what we have. See, resources where we have resources at every host. Each host has got storage, CPU, right? IO. Each host has got these things. Now, I fix something at my cluster level, 30% to my HDFS and 40% to my yarn and 30% towards my Impala. The same is applicable at every host level also. That is what we need to understand. That is the reason why we are compelled to discuss about this concept. C groups allow you to allocate resources such as CPU time, system memory, network bandwidth, that is IO, or a combination of these resources among user-defined groups of tasks, nothing but the process running on the system. User-defined groups. Sorry. Yeah. Among user-defined groups. Sorry. Whatever the resources that we have here, these resources can be assigned to the groups that you have defined, so that the process that are being initiated by those groups will get the chance of accessing those resources. By using C groups, system administrators gain fine-grained control over allocating, prioritizing, denying, or managing and monitoring system resources. Hardware resources can be appropriately divided up among tasks and users, increasing the overall efficiency. You agree with this aspect, friends? Because the resource management that we are planning or that we are trying to apply here has got well established relationship with your operating system running on each host. Operating system running on.
So Srini, how is this different from the ACL, access control list?
Access control list is in terms of accessing you know the you can say in terms of the process, right, not resources. You start defining the rules, and ACLs actually to make use of the process, what process needs to be used, and while using that process, this is somewhat related to ports and the accessibility of the kernel features, but not related to the resources, if I'm not wrong.
So basically using ACL, I can define a group and say what the group can do and cannot do, right? That is ACL.
Exactly,
So,
exactly.
but here it is, I can define what resources the group can use, right?
Exactly.
What volumes it can use and stuff like that.
Absolutely, absolutely. So
But this
this
is at the
is
kernel level. How does this interpret into the HDFS?
how does this interpret into the HDFS is because ultimately, though you are setting these things at your cluster level, but ultimately where these needs to get executed, say for example, you have the host. Now on this host, what we have is you have a task tracker and you have your data node and you have your Impala daemon. So timing you keep this Impala aside. We only talk about the task tracker. If not task tracker, we talk about node manager. If it is yarn, we talk about node manager. Now this host has got resources, right? What been mentioned by me here. Now how these resources need to be assigned to this one. So that is where we have two things actually. Static service pools and dynamic service pools. So static is something, how we do is we fix the percentage of the resources need to be used by the respective service here. That is why the name is static service pools. Okay. So we are assigning the resources to the services. With the static service pools, the advantage part is the impact of one service will not be there on the other service in terms of the resources. Whatever you are given to this particular service, it is going to be exclusively used by that service only. You know very well, under service there will be roles. If I am saying HDFS, if I am saying for HDFS service, then what roles it will have internally? Name node, secondary name node, your data nodes. All comes under your HDFS service only. But all these are individual roles. that you have within that service. So by assigning the resources in a static way, the impact of one service will not be there on the other. But the limitation is, if it is not being utilized well, resources will go waste. That is going to be a big threat in terms of working with your static service pools. It is the same, it is resource management at your individual machine level, resource management at the cluster level is no difference. But only thing is how well these are being applied. You are giving at the cluster level, but that is actually been applied at the host level. Every host connected in that cluster or associated with that cluster. So it is not just because we cannot go to each and every host and do all this configuration, right? That is the reason why we are doing at the cluster level, which in turn is applicable to every host as part of that cluster. You got the point?
Yeah.
See here. The CG config, nothing but control group configuration, nothing more. The CG config service can be configured to start up at boot time and re-establish your predefined C groups, thus making them persistent across reboots. Even if the system is being rebooted. That is the reason why whenever you make the changes here, you must restart those services. Then only the impact will happen. Till we restart those services, the impact of the changes will not be observed, will not be seen. I think you are getting the point why reboot is needed.
That is only for static, right? Not for dynamic.
Not for dynamic. Right? Here I say 35 and 30 and 35 issue. See, then only we got the chance to continue. Static service pools serve, please understand this point, which will, it doesn't need anything beyond this to understand about the static service pools. Static service pools serve to isolate services from each other so that high load on one service has bounded impact on other services. I think you are getting the point. So that high load on one service has bounded impact on the other services. So they have mentioned here what all put together 100%. That is the reason why even if you keep this one as 30, it says total is 95%. You are not able to continue. It must account to 100. You can see that here. I think you noticed here. That is the reason why we are compelled to redeploy client configuration, and I say now restart. You'll be able to see that. Stopping all services in the cluster. Stopping all services in the cluster. Then it is starting all the services in the cluster. Okay. So let us have a look at this one. In the meantime, learn, because it takes time to start those things. Yeah. So using C groups, I think you got the basic understanding. You need not master yourself in C groups again, but understanding the basic concepts needed here to understand your, because we are talking in the context of our Hadoop cluster. All process on Linux system are child process of a common parent. That is the init process, which is executed by the kernel at a boot time and start other process. That you need to understand here. So every process has got a parent process. You're getting the point here.
Yeah.
So that is the reason why, see, as init process is the one which is getting all the other process into line. So that we call it to be the root of this hierarchy, because this is a kind of tree model now. Okay, all process on Linux system are child process of common parent. The init process which is executed by the kernel, the init process which is executed by the kernel at boot time and starts other process which may in turn start child process of their own. If any child process are required, like how init is starting the other process, which we have mentioned, that we have already discussed, if I am not wrong, friends. So at boot time, what process need to be started, that we are going to configure inside. That is how your Cloudera manager is able to, your services, your Hadoop, your Scoop, all these services are getting started on the boot. So we specify that one so that these services will start at the boot time. Even at your Windows level also, you go to the task manager and you go to the specific, you go to the services, not task manager. You go to the services, and as part of the services, you select the service and you click on enable and make this to start on the startup. Then whenever the system starts, that service also starts. We need not go and start that one manually. So same like you at the Linux level. Because all process descend from a single parent, the Linux process model is a single hierarchy or a tree. I think you understand, friends, now. How come every process that is getting executed inside your Linux box or even on Windows, how come this path kind of environment variable comes with every process? Have you ever thought about it, friends? See, we are setting some environment variables, right? Java home we are setting, path we are setting and all. So how come these variables are accessible to all the process? That is where we are seeing here. Additionally, every Linux process except init inherits the environment and certain other attributes of its parent process. I hope you got this point what I am sharing here. Whatever your parent environment, environment nothing but your environment variables and the other attributes such as open file descriptors, what the parent process has got, the access, all are even inherited to your child. All are inherited even to the child. You can see that here. The fundamental aspect, if the Linux process model is a single tree or process, then the C group model is one or more separate unconnected trees of tasks. That is nothing but the process, which you can see. Um, So each process and its sub-process and their sub-process as one group. That is where the C group model is one or more separate, unconnected trees of tasks, nothing but the process. Multiple separate hierarchies of C groups are necessary because each hierarchy is attached to one or more subsystems. A subsystem represents a single resource such as CPU time or memory. The Red Hat Enterprise Linux 6 provides 10 C group subsystems listed below, and we did not work into that thing. So as I felt is the contextual, I bought this one. So if you see, these are the 10 C group subsystems what your Linux system going to provide. See here, CPU. This subsystem uses the scheduler to provide C group tasks access to the CPU. So depending on what subgroup you require, subsystem you require, which is provided by the Red Hat, you can make use of that one. This subsystem allows or denies access to devices by tasks in a C group. So in terms of C group, what resources? See here, if it is, if your C group, is associated with your devices subsystem, then this subsystem is going to allow or deny access to the devices by the tasks in a C group. So you can make one or more subsystem assigned to your C group so that based on that it is going to get the access to the resources. It is going to get the access to the resources. You see this memory. This subsystem sets limits on memory used by tasks in a C group and generates automatic reports on memory resources used by those tasks. Something related to networking and something related to namespacing and something related to CPU, related to devices. So these are what we call it to be the resources, right? So these resources are being divided into 10 subsystems, and these subsystems are being assigned to your process, so that those processes will get the access to the respective resources within what is being. Okay. So the same concept is being applied. I mean, you will not have this level of flexibility at your cluster level. The only thing is we give the resources at the service level so that the same are being, because these actual things are working on your hosts. Let you take task tracker or data node and Impala daemon. These are the things that works on every. I don't know whether you have let me see, finish. So you see here service usage, the percentage of CPU, the percentage of how much memory it is using. You see that one here. Overall CPU usage across all hosts 1.8. Overall memory used across all hosts 13.8 GB of 54 GB available. I think you are noticing that here. So you go to all hosts. There is an Impala daemon. I think you notice that here. There is an Impala daemon. And even you go over here, there is an Impala daemon running on this. Here also, there is an Impala daemon. And you have your you should have this server Impala State Store, and on this also I need to have this not been kept. Only on those four we have kept. So when you are trying to run the respective, I don't know whether you notice that or not in terms of my, let me use it from here only. Oh, it is 40, not 39. Oh, Impala not been, yes. Impala service is not been included there. We have set up the service, but that is not included in your queue. So here we have set up the Impala service, but that is not been included in your. So this is how we include the services in your queue. Though we install the service, but if it is not been assigned to your queue, you will not be able to see that service. It's taking so much time. It's fine. Let it come. So, as part of this queue, as of now, we are not seeing that Impala service, but as I've enabled here and I restart my queue, I should be able to see Impala service also here. So this, whenever you run a query using Impala, it's a layer on the top of your Hive. So it makes use of it requires its own resources, because like how you have your task tracker, you have your node manager or your data node daemons, same like you have your Impala daemon running on every node, running on every node. So it also needs its own resources for their own execution. That is why, as part of the static service pools, you notice along with HDFS and your node, YARN, we also need to give some percentage of resources to your Impala daemons even, right? So within that, they are going to actually, so within the allocated resources, your respective services are going to work so that the impact of that service will not be there on the other services. Okay, now I think we got here. So, okay, fine. This is what the property that is required. Navigator metadata server authorization. Okay, that is fine. Queue service. Okay. Because of making this change, what has happened? Because of making this change, what has happened? Not every property makes the service to get this stale configuration. So whenever we have this stale configuration, a restart is needed. So when you restart that, then only you will be able to see the changes. Restart stale services. It is going to restart. Restart now. Earlier we don't have Impala here. We only has Hive, DB query, Pig and Job Designer, but now we got Impala even here. So whenever you run the queries using Impala, it makes use of the respective daemons running on the host. So it also needs its own resources. That is the reason why we are also giving resources to your Impala along with HDFS and Yarn, right? And let us come back here. Have a look at this one. What are those 10 subsystems that are being defined here? These are the 10 subsystems that are being defined, right? If you see, for this CPU memory C group and what process running under that C group, only CPU and memory, a single hierarchy can have one or more subsystems attached to it. As a result, you can see the CPU and memory subsystems can be attached to a single hierarchy as long as each one is not attached to another hierarchy which has another subsystem attached to it already. See, you cannot make these processes to be a part of two subsystems. You can only make your process to be a part of one subsystem which you are creating. Subsystem in the sense like what been mentioned here. That is CPU memory C group. Under that you have all your process where it is only going to attach those resources, CPU and memory related resources, not the other aspects. So that way at your operating system level, you can manage your process by assigning the resources that are required. You can create these C groups and assign your process to those C groups so that the resources of the system are being well utilized or organized among the process that are going to run in that system. And this is only, see, when you are dynamically initiating some process and once it is going to finish the execution, it is going to stop, there will not be much impact on those kind of process. The life cycle is in the control of you, but we are talking about all these things in the context of at the boot time, what the process that are going to start, they need to be given with the respective resources. So I think you are getting the point, what I am trying to share here. So we are only talking in the context of the process or the tasks that are going to start at the boot level, so that they are going to run continuously as daemons, the background process. So we are more talking about those things because they are going to run continuously in the background until and unless you define the resources that need to be used, then it is going to show the impact. See, sometimes you might have noticed while working with your operating system, your certain process, they take more resources. Because of that, what happens? The other process are going to suffer. So not to happen that one, you assign resources to the C group and you make these process to be part of that C group. So what resources are given to that one? Within that only, the process are going to make use of the resources so that there will not be any impact of the services running under one group in the the services running on the other group. So that way, whatever we are describing at this level, at the cluster level, the same are going to be used. The same are going to be used even at every host level. That is the reason why we are making use of this C groups concept. That is where we are making that to get enabled. I think you got the clarity now why this C groups concept is required. Why this C groups concept is required? The C groups concept is required because whatever the percentages that we are setting here, the same applicable to the services running, the roles that are running on the individual hosts at your cluster level. Of course, we are setting this at the cluster level, but how come we can take these to the roles that are running at each individual host? Now, HDFS service we fix 30%. Now, on a particular host, what HDFS roles are running, they are supposed to use only 30% of the resources. So you may ask me one thing: how come the resource at the host level are being allocated? That is the reason why you see here. Somewhere in the point here, not. One second. Predictable behavior, prevent users from deploying the support reasonable cluster scheduling between groups of users based on the fair allocation of per group. In the static allocation only, we have one more. So I think the point is not been given here. But the point is, based on what the percentage of the resources that we have given at this level, at the static service pools level, accordingly, on each host, it is a responsibility of the Cloudera management service, because on every host we have the Cloudera manager agents running. So it is a responsibility of the Cloudera manager to ensure the same percentage of resources are also being applied to the roles running on the respective individual hosts. Are you getting this point, friends, what I shared? We are fixing 30% to HDFS here. Suppose on a particular host, there are multiple roles of HDFS. Let it be one or multiple. The reason why I am saying this one, you go to this on my secondary, I think, okay, this one. No, I think where we set up that secondary name node. Okay. Yeah, secondary name node is been set up on this one. Now imagine that on this manager.techiebs.com, on this host we have HDFS balancer, HDFS secondary name node, and we don't have any other, yes, no data node is configured here. Okay. Now, when I specify 30% of the resources to HDFS, now on my manager, where I have my two services, two roles running under the service called HDFS, these will take 30% of the resources that is specific to this particular host. So who is going to ensure that one? Your Cloudera manager is going to ensure that one. How? Because we have done the configuration at the cluster level. The Cloudera manager is going to ensure that the same percentages what been mentioned are applicable to every host. Then only we were able to maintain that integrity across the cluster, because the true storage and the true computation is happening at the host level, not at the cluster level. That is the reason why whatever we are setting at the cluster level needs to be applied to the process running at the host level, not at your cluster level. I think you got the point what I'm sharing here. Sunil, Arun, Mani?
Yeah. I got this. I got this.
Because on each host, there may or may not be, that is the reason why this has got its own limitation. Now Arun, on my manager, I have my HDFS secondary name node and HD balancer will come into picture only when you activate that. Balancer will not be running all the time. Balancer is on demand. You need to ignite or initiate the balancer. Then only it is going to balance the load on the cluster with the based on the availability of the resources there. So now I ask you, if I allocate 30% of my HDFS resources on the cluster as part of the static pool, on my manager, assume I have only my secondary name node running under HDFS service. Even then 30% of the resources needs to be given to that one. So this kind of limitations will be there as part of your static pools, static service pools, because it is done. It is done. So even if it is been underweight or overweight, we will not have any control on it. Whatever we have described and specified, within that only it is going to work. So sometimes what happens, the resources go waste. Sometimes you will see the scarcity of the resources in executing things.
So if the HDFS is given 30%, and if I have only these two roles, right, HDFS balancer and HDFS secondary name node, the entire 30% goes to the secondary name node if the balancer is not running.
Absolutely.
And if the balancer is running, does it go 15-15?
No.
From that 30% pool?
No. Depending on, that is what is again at the discretion of the cloud manager. If balancer need more and where your secondary name node needs lesser, so within that is been adjusted. Beyond that, if something is needed, the same concept of how, see, your memory is 4 GB, but still you can make many processes to run inside the operating system, provided you take care of, I think the pagination and all you are aware at the operating system level. So what happens, your data is going to be persisted, which is not being used actively now, is being persisted. And whenever you want, you can go back and get that persisted data to get back your service up and running. So same like that one here. So it is not that 15% to HDFS balance and 15% to, that is possible with your because that kind of fine grain control we will not have. We can have only at the service level. That is why this is called service pools. These are called service pools. So only at the service level we can specify, but not at the role level. So if one role is demanding more that time, then probably it get more resources. And the other one is not having, then if it doesn't require those many resources, it will not use it. But you will not have 30% divided to 15 and 15. No, not like that. Clear?
Yeah, got it.
So the same now in terms of here, let me come this way, then you'll be able to understand more. Say we can create in the dynamic resource pools, if you see, username, say for example, admin 2. So I create that. create user limit. Create user limit. So we can also go and configure, limit the number of applications that the user can run at once. I hope you are getting this here. In the dynamic resource pool creation, we have scheduling rules, we have placement rules, we have resource pools. So in the resource pools, if you see, now in the context of this one, we also need to talk about, the schedulers. See, why all these things coming into picture, tell me?
You want to be able to control the resource allocation so that you can manage your tasks, right?
Exactly. Otherwise, what is going to happen? If this kind of control, if resource management is not being taken care, then one user, now I think you noticed, one user submit 20 jobs, same point of time. Then the other users are going to suffer, right? One user consumes all the resources on the cluster, then the other users are going to suffer. Not to happen, depending on, and see, there is no thumb rule here again, and there is no best practices here. That all depends upon the need at the organization level, or in terms of the team, or in terms of the resource, in every individual resource. So there is no thumb rule that you need to give. Maybe when it comes to your static resource pools, yes, probably 35 to your HDFS, and depending again on how you are going to make use. If it is a compute intensive activity that you are working with your Hadoop cluster, then probably more resources to your resource manager, to your yarn or MapReduce, more resources. So it depends again. There is no thumb rule there, but it comes in that way. And see, pools can be nested, each level of which can support different scheduler. Now the scheduler concept is coming into picture. So as of now, we have only two. We don't have a vast variety of schedulers. We have only two. But over a period of time, I think we'll be able to see other schedulers also. As of now, we have only two. FIFO and fair scheduler are the only two things. So this is connected to your job execution only. So when you go to your resource manager, Yan is basically the resource manager only, right? How well resources are being utilized, effectively utilized. So you see, when the jobs needs to get executed, what scheduler need to be used? Of course, Hadoop is such a flexible, you develop any scheduler on your own, even that scheduler can be associated with your cluster. But by default, it has got only two. One is the FIFO. What is that FIFO? What is that
First
FIFO?
come,
Yeah, first in, first out. Nothing more.
first in, first out.
First in, first out. Okay. So, or fair scheduler. Fair scheduler, so whichever is going to come first, that is going to go out first. So, in that case, what happens? Resources are being dynamically decided based on the uh, dynamically created based on the job that is getting executed. So if it is a fair scheduler, all process, all roles, let's not talk process, all roles will get the fair amount of resources in terms of their execution. Not like, the first one is in, so I allocate more resources to get executed so that, the next one will get the chance. So both has got their own advantages and limitations. So let us not worry about the schedulers as of now. Each pool can be configured to allow only certain set of users and groups to access the pool. For running the node managers and are configured with a total of CPU cores and 4 GB of memory. 4 GB of memory. Now see here, create resource pool. You can see that. See here, I can create a resource pool, limit what are the minimum resources, virtual cores, what is the memory, maximum resources and the maximum memory, max running apps, max application master share, and the scheduling policy, submission access control, and the administration access control. So all we are giving to a pool. That is what we are saying here. We create a resource pool and based on what the resources we created. That is what I am trying to share with you here in this diagram. I think the diagram is not being kept. That's fine. That's fine. So we have a dynamic resource pool. We're not finding the diagram. No, that's fine. These are all the static service pools. But that is fine. That's not an issue. So we will be able to create a resource pool under the under yarn. You see that one here clearly under yarn. We are creating this one under yarn. So we can create a resource pool. While creating the resource pool, we can specify the resource limits. You can see the minimum resources and the maximum resources and max running applications. A limit on the number of applications simultaneously running in a pool. Now, I see here in terms of manage users. Not here. Mm, 4 running node managers are configured with a total of 4 vCores and 4 gig of memory. We need to have that. We need to give that. We are going to specify the users here. We create the pool and we assign this pool to the user group so that users will be allowed to access only within the resources that are being allocated. Where we do that is I think yeah. Configure how yarn determines in which pool an application will run. Uh, 1 second. Select. So I'll let you know that there is a no. There is no point creating the pools if you are not able to assign this pool to the applications and in turn with the users, then only it makes sense, right? So you are creating a resource pool here, and this resource pool is assigned to the set of applications and the set of users. So those users running those applications, these resources are going to be used. Then only it makes sense. Let me give you that probably in the next session. So while creating a resource pool, we also can specify, of course, resource and all we are specifying here, but this pool is going to be used by the predefined set of users for running these kind of applications. So that is what the dynamic resource pool aspect is. Not there where we have the minimum resources and the maximum resources we are specifying. On demand, the resources are going to be used. if a particular pool, the resources of a particular pool are not being used, it can be used by the other pool which we have created. Because we are specifying the range of the resources allocated to each pool here. So it can stretch between that minimum and the maximum. Not like your static resource pool where whether you use or don't use, those set of resources are going to be reserved for that one only. Of course, it has got its own advantage. The advantage is the impact of one service will not be on the other. So we go with that one when we are clear that the Impala, demons definitely need this much, irrespective of what the jobs that are being submitted or the services that are running on your cluster. If it needs definitely those kind of resources, then only we go with the static pools. But when the same cluster is going to be used by different sets of users to run their applications, then static pools will not be much meaningful. That is where we go with the dynamic pools, where we create, and we also assign a scheduling policy to this one. What scheduling policy needs to be used in terms of giving the resources within the same pool. If it is your see here, fair schedules resources fairly based only on the memory. You see, first in, first out. So whatever the job that is being submitted to the cluster first, that only is going to be executed, and most resources are given to that one. And once that finishes, it is being sent out, and next comes is the second. It is something like in a queue based. Whatever is going to come first, that gets executed, that is being sent out of the queue, the next one is going to come. And you have one more thing that is called dominant resource fairness, schedules resources fairly based on both CPU and memory. So that we will not have, that is the reason why by default it is in the DRF. And schedulers can always be plugged in. Even you develop any scheduler on your own, that is what the beauty part with your yarn. That is what the beauty part with your yarn. Yarn allows you to plug the schedulers that you develop. There is a separate API, like how we have Pig API, we have Cloudera Manager API, we have Hive API. Same like we have the API to develop the schedulers on your own, and those schedulers can be plugged in to your existing cluster, so that you can also see that that particular scheduler over here. So resource limits and scheduling policy can be decided at the time of creating the resource pool. And in order to do this one, we need to have a clear understanding of how your resources are going to be used by various applications and the user groups. So I'll give you the clarity on that one. How we assign these resources to the respective, because that needs to be assigned somewhere here only with these things. Let me look into that one. I'll let you know on that. So that whatever the resources that we are allocating for this resource pool are going to be utilized for those applications and the set of users, so that the resources that are allocated to this pool, specifically to this pool, are being best utilized. So what usually we do is we create the groups. Say for example, this is what we have different sets of users. Assume user group 1, user group 2, maybe this is for the sake of sales group, assume, and this is something like your marketing group, assume, and you have one more thing. So what we do is this group is assigned to a specific pool, and this group is allowed to use a specific set of applications. So this all tied into one thing. We have a pool assigned and a set of applications allowed to run in that pool and people who can run that one. So when we assign resources to that, within that resource only these kind of applications going to run, and these are the users that can initiate the applications. And within this sales group, each user can be given a limit of using a max of 2 applications simultaneously at any point, so that the existing resources can be well utilized by uh, the different stakeholders across the organization in terms of the Hadoop cluster. Otherwise, definitely there arises the problem that you submit. We go back to the old days, like, you submit a job now, probably after 10 hours or 20 hours, you are going to see the execution has been finished and you see the outcome of that. So not to happen that, in order to give accessibility of the resources to all the users in a fair mode, we are going to create the resource pool. Able to understand this one? Arun? Sunil?
Yes, Srinivas.
So along with yarn, we also has got the Impala admission. This is different again. So we are going to create the dynamic resource pool to both yarn and Impala individually, not like how you have seen as part of the static resource pools, everything into the same. Not like that. Here we need to create dynamic resource pool configuration for both yarn and Impala. We need to do it separately. We have a separate pool creation for yarn and separate pool creation for Impala. I'll let you know probably in the next class how these three are being put together, which the user group, applications that can be executed. Of course, user limits we have very clearly here. User limits we have clearly here. I mean, how many jobs a user can submit simultaneously, that can be controlled. But what kind of applications need to run by using this pool, and by what user group, I mean, what are the user groups that can access this resource pool, how to arrange that relation between all these three, I'll let you know, so that we'll have an understanding that, oh, this is how this resource pool by this set of users to run this kind of applications. Is that clear?
Yes.
Fine. So work on this one. I mean, I'll try to share the document that is associated with this one probably today. I think another 2 documents related to last night I shared with the team. I hope they are going to keep in the blog. This document also I'll try to share with them so that they are going to make that accessible to you. And try this Docker, Sunil, because I'm not sure whether we will be able to find, we'll be able to set up the cluster using the Docker or not. But the knowledge what I got by looking into the basic documentation of Docker, I've understood even with the limited resources, we'll be able to set up that. So if possible, please look into that one. And
Yeah, sure.
if it is feasible, then we'll try. Even I didn't attempt that one, to set up a cluster using Docker. So if any possibility of getting a document setting up the cluster using Docker, I'll try to find it out and share with you. Because on a laptop with what is the configuration that you have, 16 GB?
No, 8 GB. 8 GB. Yeah. Mine is an i5 with 8 GB.
I think it will be tough, Sunil, if we can. I mean, need to set up using VM. So each VM itself takes about 1 to 2 GB to run the CentOS. So even you create 4, I don't think you'll be able to set up that. Now 4 instances now here. You see that workstation. You need to have a 4 VMs of your
Yeah,
CentOS,
understood.
right?
Hmm.
And need to
Yeah,
assign the resources. You on all the 4, then only. And moreover, the interesting part with that is you cannot make your laptop to run 24/7. So again, you need to shut down. While shutting it down, you need to shut down the cluster and shut down the nodes, all the nodes, and make it proper. Otherwise, uh, you know, there may be a possibility on some host things gets corrupted. Then the next time when you start the cluster, we'll have the trouble again, right? I'm
understood.
also
Yeah,
looking into the possibility. I'm also looking into the possibility of giving access. But I'm not sure whether it is possible or not, because your router needs to support that, it seems, to give the access to these. I'm able to access that one, right? Because within the network I'm able to access that. So I need to find out if at all if this is possible, that is more easier to me, so that you can at least log in and see all the things, right? So
yeah,
I'll check it out
yeah.
with my networking person. If at all, if it is possible, then we need not look for too many alternatives,
Got it. Yeah.
right? Yeah, good friends. I'll catch up in the next session, um, and we'll try to see this what is left out today, and we'll also work with the performance management in the next.